Good afternoon, boys and girls. Today, what I'm going to do, since you're about to write your paper one, geography, I've been covering weather and climate. I think I've also covered geomorphology. So, what I'm going to do, I'm going to go through section B, Mapwork. I'm going to go through section B, Mapwork, for the preparatory examination 2024 geography paper 1. I'm going to go through section B. The reason why I'm doing it, I know most of the learners, most of you guys, you struggle with map work. So the aim of my lesson is to make sure that by the end of this lesson, even those guys who feel like they struggle with map work, I just want to boost your confidence. I want you to have the confidence that you can actually do far much better than the way you've been doing in Mapwork. And I'm telling you, it's possible. It's possible to perform well in Mapwork. The only thing that you need to do is just to be aware of just the basic skills. What is it that you need to do in order for you to get as many marks as possible? I know the paper is not going to be the same as the one that I have here, but here I'm going to go through section B. I'll try to give as much information as possible, and I'll also add on some information just to help you have a better understanding of Mapwork. So today I'm going to do the prep paper for last year, and then tomorrow I'll see if I can be able to do one of the papers as well, section B for Mapwork. And I would like to believe that you are fine in as far as climate and weather is concerned. But if you have got any challenges in climate and weather, please just let me know on my TikTok account. Then I can do a video on any topic that you want me to cover. And same applies with geomorphology as well. If you have got any challenges, just let me know. Then I can do, and if I can do a lesson on any topic that you feel that you've got some challenges. So let's go through the paper. So the first thing that you need to have in as far as Mapwork is concerned, guys, I want you to make sure that you have this. Make sure you've got your calculator. Make sure that you've got your calculator. Make sure that you've got your calculator. Make sure it's working as well. Okay, you've got your calculator. That is the first thing. Make sure you've got your pencil. Make sure you've got your pencil. I don't have any eraser. I'm using this one. Okay, make sure you've got your pencil. Just one is fine. Make sure you have your ruler. Make sure you have your ruler. Next thing, make sure you have got your, I'm looking for my protractor. Make sure you have got your protractor. Make sure you've got your protractor. You can see it's visible. You can see, especially when you're calculating your true bearing, you need this. You need this. It's very important. Make sure you also have your pen. The blue one, I'm going to use the black one, but make sure you've got your pen. Okay, so this is the paper that I'm going to go through. I'll try by all means to be as slow as possible so that I don't rush you. Okay, but the first thing that I want us to do before we start with the question paper, okay, here's your map. I want to show you something on this map before we start with any question. Okay, so usually you'll have your map like this. This is your topographical map. This is your orthophoto map. I want you to check something. Can you see here? This is the scale of the topographical map, and this is the scale of the orthophoto map. There's something that I want us to do. I want you to do before you start with your map work. Please do this. It will help you. Okay? So the first thing, I'll just say T for topographical. Then I'll say O for orthophoto. I'm not going to write in full. So the first thing, we know our scale is what? 1:50,000. Remember, this is in centimeters. Here we know it's 1:10,000. Okay, 10,000 centimeters. So the first thing, before we start anything, you have to know the scale of these two maps. This is your topographical map, 1:50,000. This is your orthophoto, 1:10,000. This is a ratio scale. This is your what? Ratio scale. This is your ratio scale. So what does this scale mean? It means 1 centimeter on the map represents 50,000 centimeters on the actual ground on our topographical map. It means 1 centimeter on the map represents 50,000 centimeters on the actual ground. This is your topographical map. Here it means 1 centimeter on the map represent 10,000 centimeters on the actual ground. So now that you know the scale of a topographical map, you also know the scale of an orthophoto map. This is in centimeters. I want us to convert it now into meters. Okay, let's do it. So this one remain your centimeters. So if I'm going to convert the 50,000 centimeters into meters, the first thing that I'll do is I need to know how many centimeters are in 1 meter. Okay, let me just do it like this. 1 meter, how many centimeters? They are 100 centimeters. Okay, 100 centimeters in 1 meter. So in order for me to convert my 50,000 into meters, which means I'll say 50,000 divided by 100. Why? Because there are 100 centimeters in a meter, which means here it becomes what? 1:500 meters. Remember, the meters is only applying to distance on the actual ground. Our distance on the map still remains as 1 centimeter. Okay, same applies with this one, which means if I'm to convert into meters, I'm simply going to divide the 10,000 by 100. It gives me 100 meters. So which means it's still the same scale, but what has only changed is the unit of measurement on our actual distance on the actual ground. So now it's 1 centimeter on the map represents 500 meters on the actual ground. 1 centimeter on the map represents 100 meters on the actual ground. The only thing that has changed in terms of units is our distance on the actual ground. Our distance on the map remains in centimeters. Our distance on the map remain in centimeters. I want us to do this. I want us now to change it or to convert it into kilometers. Let's do this. How many centimeters are in a kilometer? They are 100,000 centimeters. Okay, in a kilometer, the 100,000 centimeters. Okay, so how are we going to convert our 50,000 centimeters into kilometers? We are now saying 50,000 divided by 100,000. Okay, what do we get? 0.5. Okay, which means our 1 centimeter on the map in terms of kilometers is equivalent to 0.5 kilometers. We have converted now. Same applies here. We divide by 100,000. It will give us 1 centimeter on the map equivalent to 0.1 kilometers. Okay. So if you have done this, that's the first thing that you should do. The moment you get your paper, before you start Mapwork, do this conversion. Do this. Convert your scale first into centimeters, write it into meters, then also convert it into kilometers. Same applies with the orthophoto, centimeters, meters, then kilometers. What this simply means is it is still the same scale, 1:50,000, but what I've done is I've changed it into meters, especially the distance on the actual ground. I've changed also into kilometers, the distance on the actual ground. I've done the same here. Why am I asking you to do this? Because you can be asked to calculate the area and you write your answer in square meters or in square kilometers. There won't be any need for you to use 50,000. You just use 500 meters if your answer is supposed to be in meters. If your answer is supposed to be in kilometers, you just use 0.5. If your answer here is supposed to be in meters, you just use 100 meters. If it's supposed to be in kilometers, just use 0.1 kilometers. So these help you to save time. This help you to what? To save time. So this is the first thing. The moment you get your question paper, make sure you write down your scale, you convert it into meters, you also do the same into kilometers. So this remains 1. Okay, this is 1 centimeter. So this 1 centimeter on the map remains 1 centimeter. What is only changing is what is on the actual ground. Same applies here. 1 centimeter on the map remains 1 centimeter. What is only changing is the distance on the actual ground, because we are looking at the relationship between the distance on the map and distance on the actual ground. That's what the scale is all about. So make sure you convert it into meters, convert it into kilometers again. Once you have this on your paper, then I'm telling you, you save a lot of time. You are not going to struggle. Okay, let's move on now. So the first thing that I have always been emphasizing when it comes to Mapwork is you cannot start answering your 3.1 map skills and calculation without going through the general information. Okay, this is the general information of Aliwal North. Okay, this is the map that we are using. Aliwal North, this is the map that we are using. Let's go through the general information. It provides a summary about the information. Okay, let's go through it. The first thing, you already have the coordinates here in degrees and minutes and also the hemisphere. This is what you have here, okay? Alwal North, officially Malestwai, is a town in central South Africa on the banks of Orange River in the Eastern Cape province. The settlement is situated across from the Orange River, just below its confluence with the Krai River. To the southwest of the town, the Krambeek rises 2,000 meters above sea level. In Alwal North, the summers are warm and winters are short, cold, and dry. The month with the most wet days in Alwal North is February, with an average of 9.1 days with at least 1 millimeter of precipitation. So simply by going through this, there's a lot of information that we can actually highlight. Okay, that is very important. The first thing, okay, in which province can you find this? You can see here, it's Eastern Cape province. There can be a question that asks you the province where Alwal is located, okay? Where Alwal is located, okay? That's the first thing. It's situated across from the Orange River, just below the confluence in the Krai River. To the southwest of the town, the Krambeek rises 2,000 meters above sea level, okay, in terms of its location. You have this Alwal North. Here it's talking about the climate now. It's talking about the climate of Alwal. The summers are warm, winters are short, cold, and dry. The month with the most days, okay, is February, okay, most wet days. Then an average of 9.1 days with at least 1 millimeter of precipitation. You also have the coordinates of Alwal. This is some of the information that you have in as far as the general information is concerned. Then from there, let's move on to the first question now. The first question reads, in which province is Alwal North located? Let's go here and check. You have already highlighted it. It's in the Eastern Cape, which means when you come to your question paper now, your answer here is what? Is B. That's where Alwal is located. The question is saying, in which province is Alwal North located? This is where it's located. It's under the general information. If you did not go through the general information, then you are going to be confused. You understand? Let's move on to the next one. The coordinates of Alwal North is, these are the coordinates. Remember, we highlighted the coordinates. Is 30 degrees, 42 minutes south, 26 degrees, 42 minutes east. Let's go here. We have already, I highlighted. These are the coordinates, okay? The spatial data about Alwal North. Coordinates, okay? 30 degrees, 42 minutes south, and 26 degrees, 42 minutes east. So the question now is asking, the 30 refers to, all right, let's go here. This is your Alwal North. So we are saying now, here is your latitude, okay? The latitude, it increases going southwards, okay? What is changing here is only the minutes, the degree, if you can check here. It remains the same. So we have got 38 here, 39, 40, okay? 39, 40, 41, 42, then we have got 43. That's why we have got 30 degrees 43. So you can see the minutes are increasing going southwards. Okay, that's how you can identify your latitude. They increase going to the south. The degree is the same, 30 degrees, 38 minutes south. But from there you can see where the grid ends, 39, 40, 41, 42, 43. That's why we have got 43. These ones, they won't write for you, but if you count going downwards, you can see the difference in terms of degrees. That here there is what? There's a difference of in terms of degrees. 1 minute, okay, here, 1 minute, okay, this is 38, okay, 38, 39, 40, 41, 42, then you have got 43. So that is your latitude. This is your latitude. They are horizontal, okay? This one, you can see 26, 40, 39 east and 26, 44 east. It's increasing going towards the east. That is your longitude. It's vertical. 26, 39, then 40, 41, 42, 43. That's why we have got 44 here. It's increasing going towards the east. So when we look at Alwal, as it is in South Africa is in the southern and eastern hemisphere. That's why when you look at the coordinates now, you find that they give you the latitude first, then the hemisphere, which is south, which means it's south of the equator. Then they give you the longitude, which is 2642, and it's on the eastern hemisphere, which is east of the Greenwich meridian. That's what it's all about. Let's go to our question now. The coordinates of Alwal North are, you are given the coordinates that we also have under general information. So the question is asking the 30 degrees S refers to, our S is south, which means it's latitude. So which means your answer here is what? That is your latitude. That is your latitude. 30 degrees refers to latitude. Then the next question reads, refer to the graveyard in block DA on the topographical map. So the two things that you have to highlight is, what are you referring to? You are referring to the graveyard. Where is the graveyard in block D1? On which map? On the topographical map. This is very important. Refer to the graveyard in block DA on the topographical map. This is very important because if you do not use the correct map, then you are bound to write a wrong answer or to make a mistake. So please highlight, what is it that you are asked to refer to is the graveyard. Where is it? Is in block D1. On which map? On the topographical map. So now you know, when you look at your map now, you are going to get your feature on this topographical map, not on the orthophoto map. Okay, let's go and look for it now. So we have got a graveyard. Where is it? D1. This is D, alphanumeric D1. So which means, where is the graveyard? Is here. Can you see? This is where the graveyard is. This is D, this is 1. Alphanumeric alphabet D, number 1. So this is where the graveyard is. You can even use your reference just to see whether you have chosen the correct feature. You can see here it's showing symmetry, grave, symmetry, grave. You can see here, symmetry. You can see here. So this is your graveyard in D1. What are they saying now? Okay, calculate. You are doing a calculation now. Let's go to the question. Calculate the area. Calculate. What are you calculating? The area. Obviously, the area is squared. It can be in square centimeters, it can be in square kilometers, or in square meters. So it's in square meters. Okay. Of what? Of the graveyard in block D1. Okay. You are given the length, which is 1.1 centimeters, and the breadth, which is 0.7. So since you have already been given the length and the breadth, there is no need for you to go to D1 now. There's no need for you to go to D1 and start measuring. Why am I saying so? Because you have already been given the measurements. Okay, this is your length from here up to there. This is your breadth, the shortest one. Okay, but here now, we want to save time. We are not going to waste time measuring. Why? Because already we have been given the measurement, because they say, if the part which says if the length is 1.1 centimeters and the breadth is 0.7 centimeters. So the next thing that we are going to do is we are going to calculate what is the formula. Okay, what is the formula for our area? All right, area is equal to, I know it's length times breadth, but the way you're supposed to write it is length times scale times breadth times scale. This is how you calculate your area. What is your length is given here? It's 1.1 what? Centimeters. Remember, our answer is supposed to be square meters. It's supposed to be square meters. I'm using a topographical map. I have already converted here my scale into meters. So I know I'm going to multiply by 500, which means I'm going to multiply my 1.1 by 500 what? Meters. Okay? Then I'll also do the same thing. What is my breadth? It's 0.7. I'll use 0.7 centimeters multiplied by, okay, I'm going to multiply by 500 meters as well. Okay, so now that I've got the dimensions, I've already been given dimensions. I have them 1.1. I have the 0.7 I'm already given. So the only thing that I will get a mark for is using the right scale, which is 500 meters. That's what I'm multiplying with. Okay, so let's see now. All right, our 1.1 multiplied by 500, what did I get? I'll get 550. 550. Remember, this is in meters. Then I'll multiply. I'll do the same thing. I've got 550 meters. Then I'll do the same thing. 0.7 multiplied by 500 meters. What am I going to get? 350. 350 meters. I want you to take note of something, okay? What have I done here? I have written the correct unit of measurement. 1.1 is not just 1.1. 1.1 what? Centimeters. I'm multiplying by scale. 500 what? Meters. I'm multiplied by the breadth. 0.7 centimeters what? Centimeters. I'm multiplying by the scale. 500 what? Meters. So now I've done my calculations already. I'm going to take the unit of measurement of the scale, which is in meters here. So I'll have 550 meters multiplied by 350, which means this one I've got the correct measurement, I've used the correct scale. Already I have got 3 marks. Because why? I have used the correct scale, I have the correct length, which is 1.1 multiplied by 500 meters, 515. I've done the same thing, I've got 350 here. All right. Now that I have got my length is 550 meters and my breadth is 350, let me do the calculation. So I've got 550 multiplied by 350. What am I going to get? I'll have 192,500 square meters because it's area that I'm calculating. 192,500 square meters. Sorry? Okay. So this is my area now. This is my what? My area. So this is my area. All right. Let's go to the question. It has got 3 marks, of course. All right. All right. So you see here, you have got your 500 meters, you have got your 350 meters, you have got your correct answer, you've got your 3 marks. So you see, what have I done here? I highlighted the most important thing. What is it that I'm referring to? The graveyard. Where is it? In D1. Using which map? Topographical map. What am I doing? I'm calculating. What am I calculating? I'm calculating the area. The answer is supposed to be in what unit? In square meters. Okay? Graveyard, where is it? In D1. If I'm given the length, which is 1.1, I'm given the breadth, which is 0.7 centimeters. So some of you make a mistake in that. You just calculate 1.1 multiplied by 0.7, which is wrong. Because what you have been given here, you have to multiply it by the scale. Okay, like what I've done here, 1.1 multiplied by 500 meters, 0.7 multiplied by 500 meters, 550 meters, that's what I get when I multiply this, 350 meters, that's what I get when I multiply this. You can see the unit of measurement is there, the unit of measurement is here, the unit of measurement is there. So if you just say 550 multiplied by 350, it's wrong because there is no unit of measurement. If you just write your answer as 192,500 without the unit of measurement, or just meters without writing it as square meters, then it's wrong as well. So take note, guys. Use the correct unit of measurement. Make sure you use the correct unit of measurement at each and every stage. Let's move on to the next one, okay? So the next question reads, refer to the topographical map. That's 3.1.4. Make reference. I'm going to use a topographical map again. Refer to the topographical map, okay? Which means I'm using this map. The moment you use the wrong map, then you get the wrong answer, okay? Calculate, okay? Calculate, all right? What am I calculating? I'm calculating the true bearing, okay? From where? From is very important. The part which says from is very important. From trig station 56, where is it? In C2 to spot height 1398, where is it? In E2. Let me identify these two. Okay, so what we are saying is, the first thing is our trig station 56 is in C2. Where is our C2? A, B, C. All right, C2, our trig station, which means it's here. Can you see? Can you see here? All right. Yeah, that's where your trig station is. 56 is the beacon number. This one shows the height 1416.2. So 56 is the beacon number. So this is the part where they are saying from. Okay, so what I'm going to do so that I do not confuse myself, I'm going to draw a perpendicular line that passes through the trig beacon 56 in C2. This is C2, 56. I'm going to draw a straight line that passes through my trig beacon 56. That's cut through the trig beacon, that triangle. So you can see, I'm going to make it as long as possible. That's number one. This is the part which says from. Okay, that is 56. C2, 56. 2. Spot height 1398 in E2. Where's my spot height 1398? It's here. So this is the 2 part. So what I'm going to do, I'm going to connect the 2 points. The from part where my trig beacon is to the spot height 1398. So here, what do I have? I have got my trig beacon, okay, my beacon 56 here. Then I have got my spot height here. So what I'm going to do now, I'm going to measure the true bearing, and I'll do this clockwise, which means from here clockwise, which means I'm going to measure from here up to there. This is what I'm going to measure. This is what I'm going to measure. This angle from here up to there. So what I'm going to do, I'm going to take my protractor. Here's my protractor. I go where the from part is. I make sure that it's at the center. All right, I'm going to do it like this. Okay, this is the center. I'll just make sure it's exactly at the center. So if you check now, I'm measuring from here. This is 0, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170. You can see it's slightly below 180, which can be, I would take 178, 179, 178, I'll take 178, 179. I'll take that one, okay? Let me put my true bearing at my TB at 178 to 179 degrees. This is my true bearing. This is my true bearing. I have measured using a protractor. I have got 2 points. The from part is the 56 streak beacon. I've drawn a line that passes through my true beacon going downwards. Then I have identified my spot height, the 2 part. I have connected it to the from part, which is my true my trick beacon. Okay, so now I'm measuring now from here up to there. This is the angle that I'm measuring, and you do this clockwise. So which means I take my protractor. What am I going to do? I make sure that I go to the center of the part which says from. So it means I'm measuring from here, okay, going this in a clockwise direction, and I have my answer slightly below 180, which is 178 or 179. This is how I got my true bearing. I'm going to use 179, okay, but I can use also 178, it's fine. So let's move on to the next question. What is the question saying now? The question is saying now, if, all right, so what I've done is, number one, I have calculated the true bearing. Okay, I've done the true bearing. So which means here I'm going to use 179. 179 degrees is my true bearing. Okay, calculate. I'm doing another calculation. Calculate the magnetic bearing from trick station 56 to spot height 1390 in E2 if the current magnetic declination is 23. So whenever we calculate what we call the magnetic declination, we do it for the current year. So what I'm going to do, I'm going to use 2024 as my current year. Okay, so I'm going to use 2024 as my current year. I'm going to use the information that I have. I'll stick to 2024. I'm going to use 2024 as my current year, which means there is no need for me to calculate my magnetic bearing, magnetic declination. Why? Because I already have for the current year, which is what? 24 degrees, 43 minutes west of true north. This is what I have as the current year. Okay, I'm assuming that I'm in 2024. I don't want to confuse you. Okay, I'm assuming that we are in the year 2024 because the question is saying the current. So whenever we calculate the magnetic declination, of course we'll be calculating for the current year. I know the procedure that we use, the difference in years, then we do the multiplication out when we get to this. But I don't want to confuse you with that calculation. But know that when you're calculating the magnetic declination, how do you go about it? The first thing that you do is you find the difference in years, okay? Which, if I'm to take the long route, which means I would say, since I'm using 2024, I would say 2024, I'll go to this information. You can see here on the map, it's written 2017, you can see. So it will be 2024 minus 2017. That will give me the difference in years, okay? I'm just going to do the how you calculate the magnetic declination, then I'll go back to the question. So it will be 2024, it will be 2024 minus, what do I have here on the map? I have 2017. Please take note. I'm supposed to use 2025, I know, but I'm going to use 2024 according to this paper so that you don't get confused. I want to show you how you calculate your magnetic declination first. Then from there, I'll apply what is on the question paper. So 2024 minus 2017, what do we have? Okay, 2024 minus 2017, what do we have? We have got 7 years. Okay, we have got what? 7 years. All right. So once we have got the 7 years, this is the difference in years, okay? This is what we have as the difference in years, okay? We have used this. I'm using 2024. Please, I know the current is for now is 2025, but I'm using this 2024 paper. So the next thing that you have to check is your mini annual change. Your mini annual change. This is your mini annual change. 9 minutes westward, which means you now calculate what you are going to do now. You now calculate your difference in years, which is 7 years, multiplied by your mini annual change, which here is what? 9 minutes, I'll say W for westward. What will you get there? Let's calculate. 7 multiplied by 9. What is the answer? 63. So you get 63 minutes W, which is westward. So our 63 is above 60 minutes because our 1 degree is equivalent to 60 minutes. So we cannot leave it like this. We have to convert it into degrees and minutes. So it means it will give us 1 degree 03 minutes westward. Okay. So now that we have this, we are now going to calculate what the total the annual change. Okay. So which means this is what we have as the annual change. Okay, we want now, this is the annual change. Okay, the annual change. Okay, we have multiplied our difference in years multiplied by the mini annual change. Okay, that is the total change. Okay, so now we want the current magnetic declination for 2024. How are we going to do it? We are going to take what we had in 2017, which is 24 degrees 43 minutes, okay, west of true north. Then we add the annual change that we have here, because you multiply the years plus the mini annual change. So we have got 1 degree 03 minutes westward. So if you add now 23 degrees 43 minutes plus 1 degree 3 minutes, what are you going to get? 24 plus 21 plus 1, that will be 25 degrees. 41 minutes 3 minutes, 43 minutes 3 minutes, 44, 45, 46, which means you'll have 46 minutes west of true north. So this will be your current, okay, 2024. This will be your current 2024. Okay, current 2024. So why am I doing this? Because I know some of you don't know how to calculate the magnetic declination, the current magnetic declination. So the first thing, you calculate the difference in years. I'm using 2024. I know we are 2025, but I'm using 2024 because I'm using this 2024 paper. Okay, so then you get your 7 years. Then this is your total annual change, which means your difference in years multiplied by the mini annual change. Then what did I get? I get 63 minutes westward. I don't leave it like that. I have to convert it into degrees because 63 minutes is above 60 minutes. So 1 minute is equivalent to 60 minutes. So I'll now say how many degrees are in 63 minutes is 1 degree and 3 minutes. That's how I got this as my total change. Then since I've got my total change, I'm going to add it to the magnetic declination of the year that is shown on the map, which is 2017. That's why I added 24 degrees 43 minutes west of true north plus 1 degree 3 minutes westward. Then this is what I got as my current magnetic declination for 2024. This is if you are not given the information. Okay, this is if you are not given the information. All right, let's go to it now. Okay, so let's go to our question. So this is how you calculate the magnetic declination. Okay, current magnetic declination. Let's go back to the question now. What is the question requiring you to do? So we have said for 3.1 3.1.4, we have said our true bearing is equal to 179 degrees. I'm going to take 179. So this is A. Okay, this is A. Then our B is saying calculate the magnetic bearing for station 56 in. All right, and if the current magnetic declination. So which means for 2024, which was the current year that time, the current magnetic declination was 24 degrees 43 minutes west of true north. So there is no need for us to do any calculations. If they say the current magnetic declination is, you are given the current magnetic declination. So you have got the true bearing, you have got the current magnetic declination for this year. So you are supposed to calculate your magnetic bearing. What is your formula? Which is your true bearing plus your magnetic declination. So what is your true bearing? We have taken, okay, magnetic bearing is true bearing plus magnetic declination. So what is your true bearing? We have taken 179 degrees plus. What is your magnetic declination current in that year? It was what? 24 degrees 43 minutes west of true north. So which means our true bearing now, our magnetic bearing now is, our magnetic bearing 179 plus 24. What do we get? We get 203. We are going to get 203 degrees. The minutes that are left there is 43 minutes. You leave it like this. So this is your magnetic bearing. This is your magnetic bearing. That's how you calculate it. That's how you calculate according to this question. So I've used 2024 because it's given the current magnetic declination for 2024. So what I've done is I've calculated for this. I've calculated my true bearing. I've shown you how it's done. Then I move on to my formula. It's called true bearing plus magnetic declination, which means this one is already given as my magnetic declination, current magnetic declination, 24 degrees, 43 minutes west of true north is already given. There's no need for me to calculate, to use this procedure that I've used here, the difference in years multiplied by mean annual change to get my total change. It's not necessary, because I've already been given my current magnetic declination. This is how you calculate the magnetic declination. But here, I did not use that formula. Why? Because I'm already given my current magnetic declination. So this is how you get your answer for B, which is 2 marks. So you now say your true bearing plus your magnetic declination, the current that you have been given already, then you got your magnetic bearing. The magnetic bearing, you just write it the way it is, 203 degrees, 43 minutes, like that. You don't write west of true north, you just leave it like that. Let's move on. Why is it important to calculate the present magnetic bearing? It changes every year. Just the same way your magnetic declination changes, because the change of the magnetic declination also affects the changes of the true bearing. So it changes every year. That's basically what we are talking about. So basically when we talk about magnetic declination, we are talking about the angle between the true north and the magnetic north. The angle between the true north and the magnetic north. So it changes every year. If it's to the west, we add. That's why we add, okay, when we are calculating here our magnetic declination. That's why we add here, okay. That's why we are adding to this for 2017. That's why we had to add this and this. Why? Because to the west we add. But if it happens that it comes and saying it's to the east we subtract. But in most of the questions that you come across, you will always add what is to the west. It's always to the west. That's why we always add. But as long as it shifts to the east, we subtract. I don't know if you get what I'm trying to say. So it means now, here where I've got my magnetic declination for 2017 and my total change, which means if I was going to calculate if it was to the east, I was going to subtract this. But now it's to the west, we always add. But if it happens that is you are assessed saying that is to the east, which means you subtract. But most of the questions that we come across, it always asks you to add, because it's always to the west. Okay, let's move on. So the next question reads, refer to the topographical map. So the first thing that you need to know is, what map are you using? You are using a topographical map. This is our map, okay? You are using a topographical map. This is our map. What are we referring to? There is R in A3. The dominant, the word dominant, then drainage pattern in this block is, okay. When it comes to drainage patterns, okay, let's go to the area. This is R in A3. A, 1, 2, 3, when they meet. Okay, so this is where R is in A3. So the question is saying the dominant drainage pattern. You are given different examples of drainage patterns. So they are asking for the dominant, the one that is dominant there. If you can check them, you can see this is your, of course, this is in A3. The dominant, what do we have? You can see this is a trellis, because the tributaries are joining the main river at right angles, This is what we have in A3. Of course, we have just not this one. This is a dendritic, but it's not dominating. It's not the dominant here. Okay, it's joining at acute angles, of course, but it's not dominant in A3. The one that is dominant is trellis, which means your answer here, the most dominant here, is B, which is your trellis. Compare the drainage density of the area at R in A3 and S in B3. So we are saying here, where is our B3? S. This is our, this is our R, this is our S. Okay, what is drainage density? You need to have an understanding of what the concept is all about. This is the total length of streams per unit area in a drainage basin. That is your drainage density. Where do we have more streams flowing? We have got more streams on S. That's why we say it's a higher drainage density in B3 as compared to A3. Because at R we just have a few streams that is flowing. So here we have got more streams flowing per unit area, which means there's a higher drainage density. So the other thing that you need also to understand, when it comes to higher drainage density, you need to have an idea of what favors higher drainage density. Why do we end up having higher drainage density and lower drainage density? So you look at two concepts, the concept of erosion, surface runoff, and infiltration, where the topography encourages more surface runoff, which means we are bound to have more streams flowing, and where the topography encourages more infiltration, we are likely to have a low drainage density, which means there will be less streams flowing. What am I trying to say? Let's say, for instance, at S, there is a steeper slope, which means as soon as we receive rainfall there, we have more surface runoff because water is not allowed to settle for a long time so that infiltration takes place. But as soon as we receive rainfall, then we have got surface runoff. But when you talk about the at Arab, maybe some of the rocks there, they are impermeable. They cannot allow water to pass through them. Okay, let's say they are permeable, right? Okay, so that there's low density. If they are permeable, which means they allow water to pass through them, which means there's going to be more infiltration taking place there as compared to surface runoff. Why? Because they do not support more surface runoff flowing on the earth's surface. So that's basically what it's all about. So where we have got a higher drainage density, there is more surface runoff as compared to infiltration. Where we have got low drainage density, there is more infiltration as compared to surface runoff. Okay, let's move on now. So we are saying now, compare the drainage density R in A3 and S. So here there is a higher drainage density in S. Why? Because there are more streams flowing, okay, in this area as compared to A3R. Okay, let's move on. Provide evidence from a topographical map to justify your answer. Okay, let's provide evidence. Okay, here there are more streams flowing as compared to A3. So this is what supports that there is a higher drainage density in S as compared to R. Okay, this is what supports there is a higher drainage density as compared to R because there are more streams flowing at S. Okay, refer to the tributary T in block B4 and B5. Okay, B5 on the topographical map. So we are referring to tributary T and in block B4 and 5 on the topographical map. All right, so the map that we're using is a topographical map. What are we referring to? Tributary T. Where is tributary T? It's here. Tributary T in which block? B4 and 5. So we are talking about here, what is happening here in block B4 and 5. All right, so the question reads, in which direction is the tributary flowing? In which direction is it flowing? So how do we determine the direction in which the river is flowing? Number one, we look at the angle at which the tributaries are joining the main river. Let's see, this is the main river. You can see they're joining at acute angle. Of course, it's going through towards, okay, let me do it like this. This is your north, this is your south, this is your west, this is your east. So it's going towards southeast. You can see it's between south and east. It's going towards the southeast. Can you see? It's going towards southeast. Okay, we are using number one, the angle at which the tributaries are joining the major river. You can even say eastwards is fine as well. Number two, let's look at the dam wall. The river will always flow towards the dam wall, not away from the dam wall. So you can see north, south, west, east. Is eastwards or is towards the southeast. Why? Because it's flowing towards the dam wall, which means it's coming in this direction. This is your dam wall. That's what is happening. So number one, I've used the angle at which the tributaries are joining the main river. I've also used the position of the dam wall. The river will flow towards the dam wall, not away from the dam wall. So that's why I'm saying southeast or eastwards. You can see here, I'll take southeast. I think is the most appropriate one. Okay. Then you can also look at the contour lines, contour height, because the river will flow from higher land towards lowland. If you can check here, what do we have? You can check flow towards highland, towards lowland. What can we use here? You can see 1, 4, 1, 3. Here is 1, 3, 1, 6. Obviously, here is higher than here. That's where it's coming from, which means the source of the river is an upland or highland as compared to where it's flowing towards, which is the lower course. So it's from highland. I've used the contour height as well. So that's what I've used them. Provide evidence from the topographical map to support your answer. That's what I was doing. The dam wall, number one. Number two, the angle at which the tributaries are joining the main river. I've also used the contour height. Then refer to the lines 6 and 7. All right. Here, remember, we're still using our topographical map, okay? I think I've highlighted that. Refer to lines 6 and 7 on block A3 and to B3 on the orthophoto map. Let's go now. This is in orthophoto. We are referring to 6 and 7, block A3 and B3. That's what we are referring to, okay? So what is it saying now? Draw a labeled freehand. Draw a labeled freehand cross section from point 6 to 7 as shown on the orthophoto map. So the first thing that you need to do now, guys, is when you are looking at this is a river meander. This is a river meander. You can see the twisting and turning of a river. So when you're looking at the river meander, I'm going to take this as my 6. I'm going to take that one as my 7. What is happening? You have got the outer bank here at 6. You have got the outer bank at 6, then you have got the inner bank at 7. Which means when you are looking at the cross section of a meander, at the outer bank, what happens? There is more erosion. So it's deeper. That's your undercut slope. When you look at your 7, there is more deposition. So this is your slip of slope. So we are saying now, when you come now to a cross section, it's supposed to look like this. All right, why? This one becomes your undercut slope. Undercut slope. Okay, this one becomes your slip of slope. This one becomes your slip of slope, not tip. Slip of slope. So this is your undercut slope. This is your slip of slope. You have to make sure that obviously you label. This is a cross section, the cross section of meander. Of course, you have a title as well. This is from 6 to 7. A cross section, freehand cross section from point 6 to 7. Okay, this is going to be your title. Then you are showing now from 6. This is your undercut slope. Erosion is taking place, that's why it's deeper. Then this one is 7. This is your slip of slope, is the inner bank. This is where deposition is taking place. Why? Because water here is flowing at a slower speed as compared to the undercut slope. Here there is higher velocity on the undercut slope. That's why there is more erosion on the outer bank. Here the velocity is low. That's why there is more deposition taking place on the inner bank. So this is what your cross section is supposed to look like. So this is your undercut, erosion is taking place. This is your slip of slope where more deposition is taking place. So when the water is flowing on the stream, here is flowing at a faster speed, higher velocity. So it's erosion on the outer bank, which gives you an undercut slope. That's why it's deep. Here on the inner bank, there is more deposition because it's not flowing at the same velocity. Here it's slower. That's where deposition is taking place on the inner bank. That's where you've got your slip of slope. Okay. So this is your cross section. That is your answer for question 3.2.3a. Refer to point 7 on the orthophoto map. Explain why deposition is the main process taking place at this point. All right. Deposition is taking place at 7. Why? Because here the water has got a low velocity, is flowing at a slower speed as compared to 7, which is an undercut slope. That's why here there's erosion, here there's more deposition. That's what is happening. This is the inner bank, which means here the velocity is low as compared to the outer bank, which is the undercut slope where erosion is taking place. So here, since the speed at which the water is flowing is lower, that's why some of the sediments are deposited on the inner bank. So there's deposition because the water is flowing at a slower speed as compared to the undercut slope where erosion is taking place. That is the answer. Then Geographical Information System, GIS, refer to the extract below to answer question 1.3.1. 1.3.1, the new owner of the farm, Wild Plus in block E5 on the topographical map, wants to identify the best place to graze his cattle. A5, okay, he wants to, Wild Plus, you want to identify the best place to raise his cattle. You can just use remote sensing. This is straight into the point. Let me not waste time. Okay, so that the GIS process that you can find, you can actually use the, okay. So we are saying now, identify one of the GIS processes. Identify one of the GIS process the farmer could use to identify the best place to graze his cattle. Let's just straight to the point. That is your GIS. That is your remote sensing. That's what he can use there. Okay. So when it comes to GIS, this is the Geographical Information System. Okay. It is a computer system that is used to capture, to manage, to display geographical data. Okay, for different purposes. So we are saying it's a computer system that is used to capture, to record, to manage, to display, even to manipulate geographical data for different geographical purposes. That is your GIS. So when it comes to GIS, you are supposed to know the components of GIS. That is your software, your hardware, okay, your software, the hardware, the people that are involved, the methods that are used, and also the people. Okay, those are the 5 components of GIS: your hardware, your software, the methods, the data, and the people that are involved in carrying out the process that is part of your GIS. Okay, refer to all plus in A5 on the topographical map. Name one human-made point feature on block A5 used to extract groundwater. So when you talk about the human-made point feature, okay, the features that you find on a topographical map, we refer to them as vector data. They are shown as points, they are shown as lines, they are also shown as polygons. What do I mean by that? Okay, if I'm to go to A5, I'm saying now you have got a river there. That's a line feature, a vector data. Okay, we have also have this track line, okay, the one that you have. Okay, that's also a line feature. You have got this orchard or cultivated land here. That is a polygon or area symbol. We also have the buildings that we have here. This is also what a point symbol. We also have the spotters point symbol. We have also the dam hole. That is also a line symbol. Okay, let's get back to the question now. Name one human-made. Name one human-made. Name one human-made point feature in block A5 used to extract groundwater. Okay, one human-made point feature, okay, in block A5 used to extract groundwater. Let's go to A5. What is used to extract groundwater there? Let's check from our... Okay, that would be a wind pump. You can see from the reference here. I'm checking here. Let's check what we have. We have got here, what we have. We have got the wind pump here. We have got the wind pump. That's what we have, okay? Use when human-made point feature in block A5 used to extract groundwater. Okay, we have got a wind pump here. We have got a wind pump in A5. That's a wind pump that we have there. Okay, what else do we have? I'm seeing a wind pump. Okay, that's what I've seen there. Let's move on to the next one. Okay, here they have made it specific to say to extract water, but the buildings are also point symbols, but here they are being specific to say to extract groundwater. You can see in A5 here we have got a wind pump. Okay, then name one human-made feature in block A5 used to control the flow of water. Okay, human-made line feature. Human-made line feature. Line feature, remember we said on orthophoto map, there are line features, line symbols, area symbols, and point symbols. So the line feature now that we have is a dam wall. That is a dam wall. You can see there is a dam wall. Dams are constructed. That's a human-made line feature. That is a dam wall. That is a dam wall there. Then refer to image A and B on block B3 on the orthophoto map. A and B are images of settlement located in B block D3. Okay, orthophoto map. Okay, that's what we have. So here, when you look at the images, of course the other one is blurry, the other one is more clearer. We're talking about the resolution now. Which one is more clearer? That's basically what you're talking about. Which image A or B illustrates a high resolution image, which means which one is clearly visible. So you can see from A and B, this one is visible than A. You can see. So the answer there is B. Motivate your answer. This one is more clearer. That's what it means. B is more clearer. You can see it clearly as compared to A. That will be motivate your answer. Explain why images B and A are examples of raster data. Because obviously in images or photographs, they are shown in pixels. Of course, this is an orthophoto, which is an image, which is a photograph. So that's what it's all about. So boys and girls, just to conclude, Mapwork is very easy. I would like to put it that way. You have seen the way I was answering some of these questions. So what you need to know is you need to know, number one, go through the background information. That's the first thing that you're supposed to do. Number two, once you have captured or you have got the information about the background information, it can help you to answer some of these questions. Remember when I was going through this question paper, these questions, I managed to get this answer from the background information. I also managed to get these coordinates of Alol not from the background information. When I was calculating, I made special reference to say that you should know the map that you're supposed to use. Are you using a topographical or an orthophoto map? Here is a topographical map. So make sure you use the correct map. Some of you end up writing the wrong answers. Why? Because you are using the wrong map. Where is saying refer, use the topographical map. If you use an orthophoto, which means your answers are going to be wrong. Here, you are supposed to calculate the area. What did I do? The first thing that I do, I converted my map scale into meters and kilometers, so that I won't struggle when it comes to calculation. When I was calculating my area, you have to be attentive to detail. What information are you given? What information is at your disposal? You have been told that you are supposed to calculate in square meters, so you know your answer is supposed to be square meters. What are you calculating? The graveyard area, okay? Where is it in D1? The length is given, the breadth is given. So there's no need for you to measure, to go to the map and measure. You just calculate using the formula that you know. This is the formula for the scale, length times scale times breadth times scale. This one is not usually given. They just give you the length times breadth. But you should know that you multiply your length times your scale, your breadth times your scale. Same applies here with your calculation of the true bearing. What did I do? You go to where it says from. You go to where it says from. In this instance, the 56 was the from, trig beacon 56, and the spot height was the to part. So you draw a line that passes through your trig beacon, then you connect the 2 points, then you measure in a clockwise direction. That's what I've done. Then I got my true bearing, which is 179. Magnetic bearing, obviously you've got your formula, or true bearing plus your magnetic declination. What information are you given when it comes to calculation of magnetic bearing? You already have the current magnetic declination, so there's no need for you to go through the process of calculating magnetic declination from saying the difference in years multiplied by the mean annual change to get your total change. You don't have to go through that if you are already given the current magnetic declination. What you only need to do is to add your true bearing plus your magnetic declination, then you get your magnetic bearing. And take note, when you are writing your magnetic bearing, you do not write it with any units. You just write 203 degrees 43 minutes. You leave it like that. You don't say west of true north or westward. You just leave it like that. That is your magnetic bearing. So what I've done here is I've written the formula, true bearing plus magnetic declination, the current that is shown. That's how I got this. Then from the what else did you do? When you are looking now, you are using a topographical map. What is the dominant drainage pattern? I've shown you on the map that the one that is dominant there is the trellis pattern. How do you identify a trellis? Obviously, the tributaries are joining the main river at what? 90 degrees. Compare the drainage density. I have even gone to compare the drainage density in R and S. Here, there are more streams flowing as compared to R. That's why we say here there's a higher drainage density. What else did we do? We also looked at the give evidence. Obviously, that's the one that I've given, that there are more streams in S as compared to R. Then here, the direction in which the river is flowing. We are saying now, which map are you using? That's number one. Number two, how do you determine the direction in which the stream is flowing? Number one, the tributary should join at acute angle. It points towards the direction in which the river is flowing. What I simply mean is, when you come here, they are joining at acute angle, which means they're heading towards southeast. Where is your dam hole? The water will always flow towards the dam hole, so it's also southeast. That's how I got the answer. Then next, your 6 to 7, you're supposed to draw a cross section. What we have done is, you know, this is your meander. You should know how to draw and label the cross section of a meander, which means you have got the undercut slope where erosion is taking place, then you have got the slip of slope. So which means it's supposed to look more like this. This is where your 6 is, this is where your 7 is. Here erosion is taking place, there deposition is taking place, that is your slip of slope. What else do we have? We have also looked at one GIS process that can be used, that's remote sensing. Human-made point feature. Remember, we said on a topographical map, we have got line features, we have got point features, we have got polygons. So human-made point feature, where water is extracted, that is your what? Okay, the wind pump that we have there. Okay, then the line feature, that is your dam wall. Okay, then here resolution, I think I've taken you through that, you understand what it's all about. So boys and girls, the idea is to make sure that you totalize Mapwork. It's possible if you go through the concept, you try by all means to get as much information as possible. That will help you to understand or to comprehend some of these things. So what I'll do tomorrow is I'll try to do some of the calculation, but this was just to give you, to simplify actually Mapwork questions. I revised the preparatory examination 2024 geography paper 1. Thank you so much. I'll see you next time. Ta-da.